Algebra 2, 5th, 6 weeks test review. So we're going to be covering tests 5.1, 5.2, 5.3. So to begin with, let's start with section 1. Solve, round to 3 decimal places when necessary. So number 1, we've got, I'm going to go and rewrite this. 6 to the x plus 1 equals 36 to the 5x over 2. Now what we want to do here is have the same base. If we can get these two bases to be the same, we can eliminate those and just solve for the exponents as an equation on their own. So what we're going to do is turn this 36 into a 6 squared. So we've got 6 to the x plus 1 equals 6 squared, which is still 36, to the 5x plus 2. Now, we can distribute this. 6 to the x plus 1 equals 6 to the 10x over 2. Now that the bases are the same, we can just eliminate them. We don't need them anymore. We'll say x plus 1 equals, this reduces to 5x. 10 over 2 is 5x. We can subtract 1x here, subtract 1x. So we'll have 1 equals 4x. Divide by 4, x equals 1/4. For number 1. Okay, number 2. (81 to the x plus 5 equals 3 to the 2x over 3. So again, we want to get these bases the same if we possibly can. So we can turn 81 into 3 to the 4th. So this is something you'll just have to test and kind of get used to. Since we know we're trying to get to a 3, it'd be good to test, 3 squared, 3 to the 3rd, 3 to the 4th, see what you get. And you'll see that 3 to the 4th power is 81. So we're going to turn that into 3 to the 4th to the x plus 5 equals 3 to the 2x over 3. Now again, we're going to distribute it just like we did here. We did 2 times 5x over 10 to get 10x over 2. So we're going to say 3 to the 4x plus 20. We distribute that, the x plus 5 both get a 4 times 4. And this is equal to 3 to the 2x over 3. Now that our bases are the same, this is what we've been trying to accomplish. Those can go away. We can say 4x plus 20 equals 2x over 3. And now we can just solve algebraically. So multiply by 3, multiply by 3. So we'll get 12x plus 60 equals 2x. Subtract 12x, subtract 12x. So that goes away. 60 equals negative 10x. We divide by negative 10, divide by negative 10. X equals negative 6. All right, our next problem, number 3. We've got log base 3 x plus 1 equals 2. Okay. So what can we do here? Using the log rules, we know, just as a quick review, the base to this power equals this. And what I mean by that is we can rewrite this as 3 squared equals x plus 1. This is always a rule. This is always true for logs. The base to this power equals the term with the log. Now that we have it simplified, the log is out of the picture. 9 equals x plus 1, subtract 1, subtract 1. X equals 8. And finally, number 4, we have log 2x equals 2 minus log 5. So what we want to do here is add this log 5 over. Let's get the logs together. Plus log 5. So we're going to have log 2x plus log 5 equals 2. Is this equals 0 here? Okay. So the rules for logarithms, when you have addition between logs, this is the same as multiplying the terms with the log. So we're going to multiply those two terms. So we're going to get a combined log now. So we're going to have log 10x equals 2. Now we can take our, just like we did over here, we did the base to this power equals the term. The base, if it's not stated, the base of a log is always 10. So if there's no number here, it's a 10. So then we can say 10 squared equals 10x. So 100 equals 10x, and then divide by 10, divide by 10, x equals 10. If you have any questions, post them in the comments and I'll try to get back to you as soon as possible. Thanks.